Compound pendulum. A simple pendulum is said to have a point mass. In physical world, it's impossible to achieve this. Hence, mostly all the pendulums are compound. Compound pendulum is a body swinging about a point other than its CG. As this pendulum follows the simple harmonic motion, we can derive its equation of motion and estimate the time period of oscillation by the equation 2 pi root h square plus k square by gh, where h is the distance of CG from axis of suspension, k is radius of gyration, and g is the gravitational acceleration. The aim of this experiment is to determine the radius of gyration of a body. Now let's perform the experiment.
Hello, we'll be using the same apparatus for compound pendulum experiment. This is a compound pendulum. The total length of this is somewhere around 850 mm. So the CG of this body would be lying somewhere at the center, which is half of the length, 4.5 mm. There are two different holes over here from where we can suspend it. This is the point where we will be suspending this pendulum. So if you suspend it by this hole, okay, the dimension says that this length is 190 mm, and if you suspend it by here, that would be 385 mm. So we'll perform it for two different heights and we'll measure the time period for 10 oscillations. Divided by 10, you get time period for one oscillation. First of all, you need to get this thing stabilized. This was 14.42 seconds. So time for 10 is 14.42 divided by 10, 1.44. We'll do it for the other height and we'll check the results and then we'll conclude about it.
In the experiment, when h was kept as 0.385 meters, the time period obtained for 10 oscillations was 14.42 seconds. So the time period for one oscillation is 1.442 seconds. We can plug in all the details in the above equation, that is 2 pi root h square plus k square by gh, and we can get the value of k, that is the radius of gyration. I will perform this experiment for another value of h, that is 0.190, and the time period for 10 oscillations obtained is 13.91. So time period for one oscillation is 1.391, and again we have obtained the value of k. You see there is a difference between the obtained values of k for two different h, it is 0.2256 and 0.2352. Now I've got one question. What if we change? Again we have one more, or say two more values of h. Would the value of k be different for all of them, or would it be same? Please mention that in the comments. There's again one more thing that you need to know. If this is to be replaced by a simple pendulum, if this system is to be replaced by a simple pendulum, the same mass can be suspended at a length which can generate the same effect, or say which can cause the system to oscillate at the same rate. Same rate means the time period remains same. So for this, the equivalent length is given by equation L equals to k square plus h square by h. Try this at home. Take a compound pendulum, suspend it at 3 different value of h, and measure the time period for 10 oscillations. Based on that, you will be able to calculate the value of k. Now with these two details, find the value of L, that is equivalent length, and then take another mass which is of same value, suspend it at this length, and then measure the time period for that, and check if the time period for this simple pendulum and the equivalent compound pendulum is same or not. Now I've got one more question. What if we change the value of mass for the simple pendulum? Would the effect remain same? Please mention that in the comments.